NumPy stands for Numerical Python. It's a Python library that crunches numbers much faster than Python lists. It has many useful functions for processing multi-dimensional arrays, another name for tensors. For example, image processing libraries like OpenCV, Matplotlib, and Pillow use NumPy to handle color images, which are 3D tensors. Moreover, data processing libraries like Pandas use NumPy, and machine learning libraries like scikit-learn use NumPy. It's pretty much a de facto standard for tensor processing in Python. As such, PyTorch tensors have interoperability with NumPy arrays, like importing and exporting them. Therefore, it is beneficial for us to learn the basics of NumPy arrays, which is exactly what we'll do in this video. I will create a folder and set up a virtual environment to install NumPy and Jupyter. Now, I'll start up Jupyter Notebook to experiment with NumPy arrays. I'll create a notebook with Python 3 and name it NumPy arrays. And import NumPy as np, and print the version to make sure the import works flawlessly. I will show you various ways to create NumPy arrays from Python lists. Here is a Python list containing two nested Python lists, each with 3 elements. This is a 2 by 3 matrix. I'll create a NumPy array object with the Python list. x0 returns the first row. x1 returns the second row. x12 returns the value at the second row and the third column, which is 6. Let's check the data type of the NumPy array by calling the dtype attribute. It's 64-bit integer type. We can initialize a NumPy array with float values. This time, the dtype returns float 64. We can directly specify a data type when creating a NumPy array like so. NumPy has many built-in functions to create NumPy arrays. For example, we can create a NumPy array without initializing array element values by calling the empty function. The values are whatever occupies the memory allocated for the NumPy array. We can create a NumPy array, initializing all elements to zeros, by calling the zeros function. Similarly, the ones function creates a NumPy array, initializing all elements to ones. We can create a NumPy array with random values from a uniform distribution by calling the rand function. Each time calling the rand function will return different random values. Computers use a pseudorandom number generator, a deterministic algorithm for approximating a sequence of random numbers. An initial value called seed completely determines what sequence of numbers will be generated. With NumPy, we can set the seed to use the same sequence of numbers for repeated experiments for reproducibility. Again, I'll set the seed to the same value and call the rand function. The output shows the same values as the previous cell because we used the same seed to generate random numbers. We can use the zeros-like function to generate a NumPy array having the same shape as another NumPy array, with all elements set to zeros. The ones-like function generates a NumPy array having the same shape as another NumPy array, with all elements set to ones. The I function generates an array, with ones on the diagonal elements. The shape property returns the shape of a NumPy array. We can change the shape of a NumPy array by the reshape function. This is another example of reshaping a NumPy array. Let's compare the speed of Python lists and NumPy arrays. Here, 1 million values are incremented by 1 using Python's list comprehension. Now, we'll do the same with NumPy. Linspace generates 1 million values from 0 to 999,999. Plus 1 to the NumPy array increments all 1 million elements by 1. The result shows the NumPy array processing is more than 16 times faster than the Python list comprehension approach. There are many more ways to create NumPy arrays and perform operations with them. Please refer to the link for details.